Hi, good afternoon. So it was brought to my attention, we are at the central limit theorem section, and two of the videos go to the same YouTube video. So there is a video, and hopefully you've watched it. It's in both links, and it talks about what the central limit theorem actually says, which is that no matter what our population looks like, what the distribution looks like, if we start with uniform or skewed right, skewed left, any distribution at all, if you take the sampling distribution, so many samples, and look at the means of those samples, you in fact will end up with something that behaves like a normal distribution. So no matter what your population starts with, if you take enough samples of a large enough size, that sampling mean will behave like a normal distribution. So that's the big takeaway. But then the question is, how do we actually work with the central limit theorem? What does that mean as far as our calculations? And so in your assessments, you have several types of questions. And let's see, cursor is not cooperating at the moment. There it is. Okay, let me get my calculator ready. There we go. All right, I'm going to put that off to the side for just a moment. And this is what one of our questions look like in our assessment. We have a population of values, and it has a normal distribution with a mean of 88.3, standard deviation of 81.5, and you intend to take a random sample of size n equal to 49. The first question is, what's the mean of the distribution of sample means? Well, the mean of the distribution of sample means stays exactly the same as the original population mean. Let me see, my cursor's being a little bit strange here today. So this would be 88.3, just like our mean in the population. The next question is, what is the standard deviation of the distribution of sample means? Well, that we have to adjust a little bit. So we take 81.5, and we are going to adjust that by the square root of n. In this case, that is 49. And at that point, that's where we want our calculator. So bring that back over, and I will take 81.5 and divide by the square root of 49. It gives me 11.64. See if I can get my cursor in the right spot. So that's 11.64. There we go. So that would be 11.64. So with the standard deviation, we take the population standard deviation, divide by the square root of n. So that's the first question. They're just asking you, what is the mean and what is the standard deviation? The next question I have, let's see if I can get this one separated. A population of values has a normal distribution with mean of 27.2 and standard deviation of 23.1. You intend to draw a random sample of size n equal to 171. So the first question is saying, find the probability that a single randomly selected value is between 21.5 and 31.1. So if I draw my normal distribution sketch, which I always like to do, draw this normal curve. And we want to know, with our mean at, let's see, 27.2, what is the probability that we find something between 21.5 and 31.1. So I'm going to shade in that region. That's what I'm looking for. Right, and this is for a single randomly selected value. So that's the really important part here. This is what we're looking at, the wording here. We're looking for a single randomly selected. So in that case, we're going to run our calculator with a normal CDF, just like we have in the previous sections. And we will say second bars, which is distributions, normal CDF. And I'm running from lower bound 21.5 to upper bound 31.1. with our mean, we have to enter, is 27.2. And our standard deviation in this example is 23.1. So that's all the information we need, and that area is 0.16448. I'll put, let's see, I will enter, I can find my cursor again, on a white background on a white screen. Sometimes it's hard to find where the pen exists. Okay, there we go. 0.1644. I'm going to double check that number. 1644. I'm actually going to edit that because if it's rounded to 4 decimal places, that would actually round up to 5. So let's change that to 0.1645. Find my cursor again. There we go. That's 4 and 5. Okay, so how does that change from one question to the next? The next question is find the probability that a sample of size n equal to 171 is selected with a mean between 21.5 and 31.1. So this means we're looking at the sample means. And just like with the last example, we are going to do this problem exactly the same. Oh, I didn't hit second. There we go. Second bar is I have normal CDF again. We put in all the same information. We're looking for endpoints 21.5. I'm going to 31.1. My mean is the same, just like the last example, but my standard deviation this time, and I think that you can put this right in as, let's see, that was 23.1 divided by the square root, in this case, of 171. And so we adjust the standard deviation, and I get 0.9857. Back over, find my cursor. I have already forgotten the number. Give me 1 second. 9857. See if I can get my cursor right where I want it to be. There it is, 0.9857. There we go. Okay, so that question, you do the exact same thing, but the wording is really important. If it's a single randomly selected value, you type in lower bound, upper bound, mean, and standard deviation. If it is a sample of size n equal to 171 that's randomly selected, then we use our lower bound, upper bound, mean, and we adjust that standard deviation by the square root of n. In this case, it was 171. All right, last question I have for us today. Let's see if I can get this to head to the top and give us a little space. Now we have a population of values with a normal distribution with mean of 87.3. So as always, I will draw my sketch. Here we go. Here's my sketch. My mean here is 87.3. Standard deviation is 47.8. We have a random sample of size n equal to 97. Now we're looking for the 85th percentile. So that piece of 85 is the values. Now we're looking for an x value that separates the bottom 85% from the top 15%. Let's see if I can sketch that. So I have some value x here, such that over here, this shaded area is 0.85. And the area, so that separates the bottom 0.85 from the top 0.15. And so at the beginning, we're looking, this first question is asking, what's the score separating? So the one score. And that's right here. This is the wording that tells us that we just input everything the same as we normally would using inverse norm this time. When we're looking for this x value, right here, we want to use inverse norm rather than our normal CDF. And so here, Find my calculator again. I'm going to clear out the old stuff. I'm going to put this down here a bit so that I can see the calculator and also see all my information. This time I go second vars, scroll down to inverse norm. And now we're looking for the area under the curve, which is 0.85. And then we enter the mean, which is 87.3. And standard deviation is 47.8. So I have 136.84. So I will enter that back in over here. 136.84. So that's that x value over here that we were looking for. Now the next question is find the percentile, the 85th percentile, which is the mean separating the bottom 85% of means from the top 85% of means. So this is the exact same drawing, same idea. The only thing that we're going to change is that standard deviation. And so this time I choose inverse norm. Second vars, go down to 3. This is our inverse norm. I enter the same thing. 0.85 is the percentile I'm looking for. 87.3 is our mean. The mean doesn't change. And then our standard deviation. This time we take 47.8 and divide by the square root of our n here is 97. Add my parentheses. And this time I get 92.33. Let's see. So I have 92.33. So hopefully that will help you a little bit. I did not realize that both videos went to the same explanation video on central limit theorem. I didn't see that those two links were exactly the same. So I created my own to help you out. Hopefully this